Alright, today we'll be talking about volumes and especially the two methods of the disk and the washer. Okay, so this is borrowed from Krista King over at integralcalc.com, and it's a great little helper, sheet to help out with, okay, how do I organize my information for disks and washers, and how do I go about it? Okay, so the disk and washer method actually goes off of this idea. Volume of any shape will be the integral from a to b of a of x, which is the area of the shape, times d of x. Okay, well, it's not times d of x, but it's just d of x. Now the d of x would represent the height, and if you remember, d of x is or dx is actually the width of the actual rectangles that we used to deal with in integral calculus. Now we're applying them to the actual height of the small amount of disks or washers that we're going to use to actually find volume. Okay. All right. So just some things about this little table right here, volumes by disk or washer. Okay. How do we know where we're rotating about? Well, if we're rotating about the x-axis or y-equals, okay, we will be using this column, and if we're rotating about the y-axis or x-equals, we will be using this column. Okay, now the functions in the form of this column right here are going to be y equals f of x, where it's y in terms of x, and this one's going to be x in terms of y. Okay, now the radius for the disk is going to be f of x, and the radius for the disk in terms of y is going to be g of y. Now, when we're rotating about the x-axis, we're going to make a shape that's going to be like a sideways cylinder, and then if we're rotating about the y-axis, we're going to be rotating around the y-axis, make it look like a regular cylinder. Same thing with the washers. Okay, and if you could pretend like the middle was just blank and there's nothing in between, you know, instead of just white. Okay, now the integral is actually going to be the same as what we have, except now we're going to be using pi r squared and pi r squared as well. Okay, so that's especially when we're working with disks and washers. If you're using, there's not going to be a way to do any other type of shape for the area, because you're rotating around the axis and you're going to be creating either a cylindrical-like object or a washer-like object. Okay, all right, now let's go practice some problems. Okay, so we're going to find the volume of the region bounded by these curves rotated about the y-axis. Okay, so we're rotating about the y-axis, so this is what we're going to be using. So about the y-axis, we'll be using all of this information. So we're going to set up our volume formula as v equals the integral from a to b of a of y dy. Okay. Alright, so we will be finding the volume of the region bounded by these curves, rotated about the x-axis. Okay, so that gives us a big hint that going forward, if we're rotating about the x-axis, we're going to have it in terms of y equals f of x, and we will be using this formula, the integral from a to b of a of x dx. And remember, a of x is going to be pi r squared. Okay. Alright, so first off, we're going to take a look at the actual graph. Okay, so here's the actual graph and what it's going to look like. Now, if you notice, there really isn't kind of like a straight line right here, but that's because the square root function doesn't go back any further. Okay, so it's kind of like this region right in here. So if I actually put some inequalities in here, you would be able to see it a little bit better. So let's go less than or equal. Let's go y is greater than or equal to that, and x is less than or equal to that. Okay, and if we all change them to the same color, use black. Okay, we're talking about this region right here. What we're going to do is rotate it around this axis. So this is the very middle. So whenever you see like y is something to 0, okay, you're going to be rotating around that point. And so if you look at all these intersection points, let's go boom, boom. Okay, these are going to be like the 4 corners of what I'm working with. Okay, and so when I rotate it, I'm going to be creating a bowl-like shape, except with no hollowed out portion. Okay. Okay, so we're now back to the actual curve now that we've looked at what's going on. Okay, so what we're going to do is, first off, we're going to find radius. And radius is actually going to be our function, which is the square root of x plus 3. Okay, and it's going to be minus the middle function, which is going to be 0. Okay, so this just helps us practice for washer method too. So our radius is just basically the square root of x plus 3. Okay. Alright, so when we set it up, and also our boundaries are going to be from 4 to 0. Okay, so we at least have the boundaries. So let's set up the problem and see what the next step's going to look like. Okay, so it's going to take a look like this, and then our volume is going to be the integral okay, and we're going to bring the pi out front actually. Let's put the pi out front and just leave it right there for now because that's a constant and everything. So we're going to actually go ahead and multiply this out. So this is going to be x plus 6 root x plus 9. Okay, and then have that be d of x. Okay. And then we set it up to volume is going to be equal to, now that I have that all set up, I'm going to actually find the integral, so 227. Okay, and so this is going to be 1/2 x squared. I believe I have plus 4x to the 3/2. Okay, plus 9x. Okay, and then we have it all set up like right here. Okay, our integration from there. Okay, and obviously since we're going from 0, we don't have to find the other part. So here's what this is going to be. Okay, so when we get all said and done with this, this is going to turn into 1/2 because it's 1/2 of 4 squared, which is 8. This is going to be 4 times 4 to the 3/2 power, which is 32, and then 9 times 4 is 36, and we get 74 pi as our actual volume. Right? And that's how you find the volume of the region bounded by that. Now, if we were dealing with working with a washer, okay, all you would need to do is find the inner function and the outer function and subtract the two as you're working with the radius, okay? So that's going to be pretty easy when working with that stuff right there. Alright, well that's it for working with the disc and washer methods. I'll talk to you later. Bye.